So good morning. My name is Meera Christopher. I'm from Chalmers University, Sweden. And my story begins with bark, which is a very valuable but highly underutilized resource from forest industries. In fact, it is estimated that 359 million meter cubes of bark residues are generated annually, and most of it is simply burnt. But bark actually contains a lot of sugars, fatty acids, and other compounds, which in turn can be used to create different chemicals and materials. Now, there are established methods for extracting these compounds, but most of them rely on the use of harsh chemicals, which are not so good for the environment. We are trying to do this using enzymes, specifically enzymes like cellulases, hemicellulases, and LPMOs for releasing sugars, and suberinases for releasing fatty acids. Enzymes are proteins which are released by all living organisms, and they are good because some of them can very specifically cleave large complex compounds into smaller molecules. And compared to chemicals, they work at relatively milder conditions. But one of the characteristics of bark, which makes it quite challenging to work with, is that it contains a lot of phenolic acids and tannins, which are released when we process it, and which create an acidic and rather difficult environment for normal enzymes to function. So from where did we get enzymes that can actually work? So luckily for us, we have a collaboration with the Forest Industries Research Institute in Vietnam, from where we got fungi that were isolated from extreme environments, such as acidic waste canals, mines, etc. So as you can see there, we first checked to see which of the fungi can grow at low pH and in the presence of bark-derived inhibitors. Then we sequenced their DNA to find which of them contain the enzymes that we are looking for. And currently, we are working on characterizing these enzymes and their activities. So we are looking at different things, such as under what conditions are they produced, and on which materials do they act best, and what are the structural features that distinguish them from similar proteins. And through these efforts, we aim to develop bioprocesses for enzymatically valorizing bark, or as we like to call it, barking up. And along the way, we also hope to discover and describe new and interesting enzymes. Thank you.